Wow, what a joy. פשוט רציתי להגיד, ממש שמח להיות כאן. Really, what a joy to be able to speak to an Israeli audience here. And part of what I get to do as part of our company, Advancing Eco-Agriculture, is to start to facilitate these relationships of collaboration and complementing other international efforts in moving regenerative agriculture to become the mainstream norm. And we're excited to say we're starting to see that as we begin to build those relationships and work alongside great organizations like RegenIL and others. And perhaps one of my biggest passions is the fact that the regenerative agriculture message, when fully understood, is a hopeful message, because underlying all of what we've done as a company since 2006, when our founder John Kemp first started EA, has led us to the real time and the real world discovery that these solutions that we've talked about at an ethical, moral, ideological level in practice are also very true and very rewarding for those that would pay attention. So the future really is regenerative, and an exciting one, even if there are some challenges along the way. Two things to address really quickly, which is there are two, I would say, progressive, more prominent mentalities growing within the world of agriculture. Number one, the mentality that a switch to regenerative agriculture is going to be a very quick utopian journey. In other words, we just need to put out some cover crops. We need to be more friendly. We need to stop doing tillage, et cetera, and everything very magically will work in our favor. When obviously on the ground, for those of you that are actually directly connected to working in the agriculture industry, know that this is so far from the truth of so many growers. Now, caveat to that, of course, is that along our journey and my journey within Advancing Eco-Agriculture, we do see every now and then some borderline miraculous things happen in very specific ways. And I'd love, as Gadi mentioned, to share some more of those stories with you in the webinar series that we have planned, along with the contributions from John, our founder. The other mentality, however, is also around this J-curve narrative, or simply put, that when farmers make a transition from a conventional model to a regenerative agricultural practice, they should anticipate a 3 to 5 year journey of economic decline and performance decline before all of those systems work in their favor to where they can become profitable again. And I would say this mentality, this model, this expectation is based on a number of false assumptions, but also more importantly, that if you're thinking about losing money for the next 3 to 5 years, it's obviously an incredible demotivator. And so what we need to be able to have in our movement, rather than demanding a sort of a cold turkey adoption, 180-degree different turnaround in practices and approach, we need to be able to justify and prove and support the decision-making processes supported by data to show a pathway towards a profitable regenerative transition. And we've been able to see that time and time again. And so if you want to, for example, incorporate practices that are going to facilitate you being able to deal with pests and diseases through nutrition, then you're going to need to have insights and data to support those decisions, and for us to ultimately earn the right to make those rapidly different decisions. Excuse me. So 3 key factors for us to look at when we consider regenerative transition and how we make this future a bright and hopeful one of regenerative ag, and how we make it the mainstream norm. Number one, we need to demonstrate profitability. One of the things I see a lot in my work is obviously with our podcast that John does, and with the open source information we put out there, we see a lot of, if you like, regenerative light bulbs, or discoveries and sort of revelations happen where people understand from a theoretical perspective that this all makes sense, and then they go about making those practices, and sometimes with mixed results. However, for what most growers have in common, especially in the conventional agriculture world, is what you're suggesting, is it going to be profitable? So number one, we have to be able to create a model of transition and practices that prove out profitability, and we need to have data to support that. Number two, if we're going to talk about this being a legitimate way to do agriculture in the future internationally and as a mainstream norm, it has to be scalable. So in other words, we have to create large-scale solutions for large-scale problems. When you are a grower with limited resource and limited land, a lot of solutions look very different compared to obviously when you're working on 500 hectares, 1,000 hectares, and so on. So we have to have something that works at all scale. And then again, as I've already said, we need to have supporting and real world data to demand and create pathways to success. Here's an interesting one. There's a lot of information in here, but this really ties into one of the aspects of what profitability can look like when we start to reconsider how we can actually take an approach in regenerative agriculture that creates improved performance of the crops and therefore profitability. Most folks are presuming these days that photosynthesis is just a basic process that happens because we have sunlight, water, oxygen, and so on, and we create these chlorophyll actions within crops, and it's just kind of, it does its own thing. However, what we've seen in the US, for example, is that most crops nationally across different crop types are performing at about 15 to 20% of their photosynthetic ability. In other words, they're performing very suboptimally. Now, obviously, there's some pieces in there that are tied to, for example, sunlight and so on, and cloud. Those things are out of our control. But what we can do is start to create solutions that are tied to improving the ability of plants to photosynthesize. And when you look at this example right here on the screen, when you take photosynthesis from just that 20% performance model to a 60% photosynthetic ability, we're now talking about massive yield increase, massive amounts of increase of stored carbon. In fact, we're talking about 5 times the amount of stored carbon in every 24-hour cycle just by moving the photosynthetic ability upwards to 60%. The other core piece of our approach, of course, is that crops can completely become completely resistant to pests and to diseases. And we built a whole plant health pyramid as a resource for both growers and the academic world to say, look, this is what needs to happen in plant physiology for you to expect to see a decline in various specific diseases and pest pressures. And as we mentioned, we need to create large-scale solutions here. At the risk of running out of time, I'll just speed up here a little bit to say, some of those real world solutions, for example, this particular grower, to give an example, this is about 500 hectares in Mexico of high production, high ROI vegetable production. And in these greenhouses, after our use of sap analysis and reviewing the fertility program, we were able, after 4 sap tests, to reduce the fertility cost by about 30%, as well as identify many micronutrient products that were being utilized that were having no effect on the plant performance at all. And when you think about, high value crops having high budget fertility programs, etc., this data is gold. And so to be able to make very large adjustments to the program at large cost savings and increased profitability within the first month is pretty exciting. So I feel that way. I hope you do too. And some of those things were, mapped out very specifically. When you look at some of these micronutrients, we were able to times 3, times 20, times 100 the amount of nutrition that was actually making its way into the crop. So pretty exciting stuff. For those of you who've never seen sap analysis, it's essentially like a blood test for your crops. And these were some of the tests that reviewed that demonstrated that we were seeing products that simply weren't working. So all of those levels in red were indicative of nutrients not moving through or in the plant. The other one last gift, perhaps, that sap analysis, as we look to technology to the future of how we can improve profitability and measure and substantiate the claims of the regenerative agriculture movement, is that with our use of sap analysis, we're enabled to give farmers an ability to look 10 to 14 days ahead into the future before they see any visual signs of disease or pest pressure or deficiency. And so this was a charted out model of tracking calcium as the fruit load came on the crop, to see that decline, and then the spike going up on the right as well was when we started to apply calcium foliar applications that actually worked. So lastly, in summary, if we're going to make a transition to regenerative agriculture that is a viable model, a hopeful model for the future, that can be adopted across mainstream global agricultural communities, we need to earn the right to make these big changes. We need to be able to say we can reduce the use of fertilizers because we have soil test data, other supporting data to substantiate the decision to do so. If we're going to talk legitimately about our ability and other companies' ability to reduce pesticides, then we need to utilize testing like SAP tests that can help demonstrate there is physiological and immune health within the crop that would prove out that the crop itself would absolutely be immune to those disease and pest pressures. And we do that through SAP analysis. I know a lot of the community is familiar with BRICS and overall sugar levels, although my question to the world of using BRICS tests is going to be, of course, what do you do next? Once you understand where the sugar level is, and if it's low, what do you do? What's the actionable items? And so when we look at all the practices that we could be incorporating, what are we going to do with the data? Is the data that we have simply informing us about what is going on, or is it actionable? And I want to encourage us all, as we participate in this challenge, is let's figure out ways to substantiate the impact, not just anecdotal stories, but let's prove out with data and with hard science that these changes are legitimate and having an impact, and they're there to make practical real world solutions instead of just essentially a story that remains in the science book. And I think with that, I will land there.